Up to now, we've been thinking about how a solid ionic compound dissolves in water, but that's a reversible process. And the reverse reaction is precipitation. So let's see how that works. We have here on the right some 0.1 molar aqueous sodium chloride, and on the left some 0.1 molar aqueous silver nitrate. You may notice the silver nitrate's kept in a brown bottle, and that's because, if you're familiar with photography, you would know that silver is light sensitive. In fact, there are some streaks going down the front of this bottle. That's from some drips of silver that have been exposed to the light. So I'm going to put on some gloves so I don't get stripes. So we'll take some of our silver nitrate solution and put it here in the left-hand beaker. Notice it's a colorless, clear solution. And we'll take some of our sodium chloride and put it here in the right-hand beaker. And we notice that too is a colorless, clear solution. Well, let's see what happens when we mix these two together. Let me put the silver in front and pour in some of the sodium chloride solution, and a white solid forms. That's a precipitation reaction. In fact, I can continue to add sodium chloride and continue to form more and more white solid. So we have just witnessed a precipitation reaction. The challenge, of course, is to figure out what was going on chemically during that process. If we think about what's going on when solutions of sodium chloride and silver nitrate are mixed, there are a lot of possible interactions. In solution, sodium ions and silver ions can interact. However, they are both cations and they would repel one another rather than come together in a solid. Likewise, chloride and nitrate can interact, but they are both anions and would repel one another. To form an ionic compound, we need one cation and one anion. Sodium chloride is already dissolved in water. If those ions interact in solution, we know that they would prefer to be apart as ions. Same with silver and nitrate. That compound was already dissolved, so it would not be the white solid that was observed. Sodium and nitrate are a possibility. However, if we were to test the solubility of solid sodium nitrate, we would find that it dissolves. We also know that it is soluble by our solubility rules, so that combination of ions would not form a solid. The only other combination remaining is silver and chloride. We can identify the solid as silver chloride. Another way to view this reaction is as an ion exchange reaction. Any new solid that forms from two solutions mixed in this way must be from new combinations of cations and anions. Think of the ions as changing their dance partners. Instead of pairing with chloride, what if sodium pairs with nitrate? Coming back to our solubility rules, the combination of sodium plus nitrate would be soluble both by rule number 1 for the sodium and rule number 2 for the nitrate. If the combination is soluble, that means that it does not precipitate. After swapping anions, the other combination would be silver and chloride. Silver does not appear on the soluble list. Chloride does, but silver is an exception to the soluble rule, meaning that this combination is insoluble. If silver chloride is insoluble, then it would precipitate. There is some language that surrounds the precipitation process. Even the word precipitate can be used as a verb or a noun. We would say that the silver chloride precipitates from solution. Here we're using the word as a verb. We would also say that silver ions and chloride ions form a precipitate of silver chloride. Here we're using the word as a noun. Finally, what about the sodium ions and nitrate ions? What are they doing? Well, they're still in there, but they're not participating in the precipitation process. They're just watching, so we would call them spectator ions.